Ba-da-bum-bum-bum-ba. Alright, what's going on, dudes, and welcome to the start of a new adventure. As of late, it seems that many Skyblock fans have expressed a certain nostalgia towards the survival aspect of the original 17 episodes of the series, and seeing as I try my best.
It is me, Gru from Despicable Me, and today we are sponsored by Raid Shadow Legends. Choose your character. Play now and get one of my minions. Don't worry, Mama. Look, it's Kevin. He's definitely going to win. Get ready to raid your book.
Oh my gosh.
Don't you hate when this happened to you? Me too. I have the perfect solution for you. The center of mass calculator. So the center of mass calculator can calculate the center of mass of any object you want. Notebook? It can do it. Shoe? It can do it. Your mother? It can do it.
What? Whether you're an average Joe or a rocket scientist, this product is for you. Now I bet you are wondering why center of mass is so important. Well, to answer that, center of mass is the point at which a force can be applied to an object without causing that object to start spinning or tip over. Remember that car crash earlier that led to Gru's demise?
Center of mass played a large role in determining how exactly those cars flipped over. To further explain, center of mass is what determines the tipping stability of an object.
Objects with lower center of mass will topple over with less ease and vice versa. For example, look at this box. No, that box. Over there. Yes. This dot in the middle is the center of mass. I'm pointing.
Here's a real-life example. Look at this book. This arrow pointing down is the force of gravity acting on the book at the center of mass. When the arrow exceeds the point where it has contact with the table, it tips over, as shown.
Welcome to Cool Academy. Today we'll be discussing center of mass. I will be drawing two objects, both of equal mass, and the point at which the center of mass is located in between these two objects. Here is an equation for the center of mass. Go.
This is our center of mass calculator. It's so powerful that it can calculate center of mass in a blink of an eye. Oh no! What is that?
Damn.
You have failed me for the last time.
Hey guys, it's Cool Academy back at it again for another video. This drawing right here is of a graph we will be graphing h of x and g of x, two nonlinear functions. As you can see, they're nonlinear and they intersect at point B. H of x is on the bottom and f of x is on the top. So, since we know that f of x is on the top and h of x is on the bottom, we can subtract them and find the area between the curves. We know it goes from A to B, so we'll take the integral from A to B of f of x minus h of x to find the area between the curves.
We already determined that you can find the area of an object using integrals, but since we're dealing with real objects, we need to account for density too. And we know that mass equals the density of the object. Times the area of the object, which we have already found to be the integral, which is shown here above. All objects have moments acting on them about the center of mass, and on a two-dimensional plane there are two moments, one in the y direction and one in the x direction. Moments are just the product of the mass and the distance from the center of mass. We also know that the center of mass coordinate about the x-axis times the total mass of the object equals the moment about the x-axis, and the center of mass coordinate on the y-axis times the total mass equals the moment about the y-axis. These equations can be rearranged to solve for the coordinates of the center of mass, so that the center of mass coordinate on the x-plane is moment of x over mass total, and the y-coordinate is moment about y divided by the total mass. I bet you're wondering what these moments really are in equation form. So here they are. The moment about y is the density of the object times the integral from a to b of 1/2 f of x squared minus h of x squared dx and the moment about x is the density of the object times the integral from a to b of x times f of x minus h of x dx.
Now that we know the moment of the x and y direction and the total mass, we can solve for x center mass and y center mass. So x center mass equals density, and the integral from a to b of x times f of x minus h of x dx over density times the integral from a to b of f of x minus h of x dx. The y center mass would be similar, just using the moment from the y direction, which is density times the integral from a to b times 1/2 f of x squared minus h of x squared dx over density times the integral from a to b of f of x minus h of x dx. And density cancels out from both the top and bottom, and that's it. Thank you guys for watching. Cool Academy. Back at it again. Subscribe.
You got a friend in me. When the road looks rough ahead and you're miles and miles from your nice warm bed,
You just remember what your old past said. Or you got a friend in me.
yeah, you've got a friend in me. You got a friend in me.
Oh yes, the center of mass calculator saved my life.